Okay, today we're looking at vectors, part of our unit looking at right triangles. One thing about vectors, the definition, when we're talking about vectors, we're talking about something that has magnitude and direction. Now, magnitude, when we talk about magnitude, we're talking about the distance from the initial point to the terminal point. That distance is the magnitude. If I have a vector that starts here and it goes to there, that distance is the magnitude. Now, if it's shorter, that magnitude is that distance. Now, the direction, and when we're talking about the direction of a vector, we're talking about, for instance, if I have a vector, let's do this. If I have a vector that is going this way, well, and I have another vector from that same point going this way. Just to say upper right hand, it goes to the up and to the right, or up. That's not clear enough. We need more specific directions, which is why we use the compass directions when talking about direction for a vector. And the way we do that, we're talking about, for instance, this example, this angle is 25 degrees. So this vector, the direction this vector is going is 25 degrees south of east. If we're at east and we're going 25 degrees south, we would go to this point where that vector is. Another example would be if I have this and it's 15 degrees, well, this vector is 15 degrees north of west. Okay. Another one, we'd put that one there and say this was 45. That would be 45 degrees east of north. Okay. I'm abbreviating it. I would rather you write that out. So here we're adding vectors now. The way we add vectors is all we do is we add the x's and we add the y's, and those are the coordinates for our new vector. Now, supposing that I had a vector of a ship. This was the vector of the ship. And likewise, I had the vector of the ocean current going this way. Well, that ship is going to have to deal with that ocean current, and it's going to cause that ship not to drive in a straight line, but it'll push it the direction of the other vector. So the two vectors in connection with each other are going to create the vector, the actual direction the boat would take. We would do that. We'll say that the coordinate for this is going to be -2, 3. And the coordinate for our current is going to be 3, 1. So, what do I do when finding my new vector? I take the x's, -2 and 3, add them to each other. -2 plus 3 is 1. And then I take the y's, 3 plus 1 is 4. And that would be, those would be the coordinates for my ship taking into account of the wind, which would be somewhere here. That would be the drawing for my new vector, roughly close to that. Okay, let's continue looking. Let's take a look at the assignment. There's a few things on there that we could do together. All right, again, adding them, you add the x coordinates, you add the y coordinates, 1 and 2, you can do that. 3 and 4, very similar. What we first have to do is we have to find the coordinates. We'd say this is the coordinate of this vector, this is the coordinate of this vector. So the first one is 1, 2, 3, 4, 5, 6, -6, down 4, -4. And the other vertex, or vector, would be -3, 2, 3, 4, negative 6. Add those together. Again, x is negative 3 plus negative 6 is negative 9. And the y coordinates, negative 4, negative 6, would be negative 10. So those would be the coordinates for your new vector. That point would be right here, and the drawing for your new vector would look like that. Okay, you can do 4 on your own. Now I do want to talk about 5. All we're doing here is describing the direction. This is 15 degrees south of west. I'll let you do 6 on your own. Okay, number 7, kind of a tricky problem here, but really it's putting all of our stuff together makes a little bit more sense, all the tangent and all the trig ratios we've been looking at. Now the question wants us, it gives us the length of the vector, it gives us the angle, 48. It wants us to find the coordinates of the terminal point of our vector. Well, you'll recall that if I make a right triangle with the x-axis and I find the length of this side of that triangle, that will give me the x-coordinate, and if I find this side length, that will give me the y-coordinate. So this is where my trig ratios come into place. I'm going to use SOHCAHTOA to do this. Now with this triangle, the 900 is the hypotenuse, and actually let me do that in a different color. That's the hypotenuse. In relationship to the 48 degrees, the x is adjacent and the y is opposite. So I'm going to use one of my ratios. Which one? If I'm finding x, I need to use my adjacent and my hypotenuse. Obviously, I wouldn't be using the opposite side because that would be another variable to throw in there. So, which one uses a and h? That would be the cosine ratio. So the cosine of my angle, which is 48 degrees, is equal to my cosine ratio adjacent over hypotenuse. Again, adjacent was x, hypotenuse was 900. Then I solve for x. Multiply both sides by 900, which cancels that out, and x equals 900 times the cosine of 48. When I plug that into my calculator, you should get an x value of 602.2. Okay, now let's take a look at the y. We need to solve for the y coordinate, which trig ratio uses opposite and hypotenuse. Well, that's going to be the sine ratio. So the sine of my angle, which is 48 degrees, is equal to the sine ratio of opposite over hypotenuse. And I'm going to do the same exact thing. Get the 900, multiply it, so that basically x equals 900 times the sine of 48. And when I do that, I find that y equals 668.8 when rounded to the tens place. So my answer, there's my x-coordinate, 602.2. Here's my y-coordinate, 668.8. And those are my x and y coordinates of my vertex. Okay, use that as an example to help you solve number 8. Number 8 is identical. Number 9, a little bit different here because they do the opposite. They give us the x and y coordinates, or the x and y, or actually the two legs of this right triangle. What they want us to find is the length, the magnitude of our vector. Now, if that's a right triangle, which it is, we can solve for, we'll call it C, by using the Pythagorean theorem. 300 squared plus 640 squared equals c squared. Remember, the Pythagorean theorem is used when we have two sides of a right triangle and we're wanting to find the missing side. So then I end up with 90,000 plus 409,600 equals c squared. When I add those together, 499,600 equals c squared. Take the square root of both sides, and when I square root this number right here, I get c equals 706.8. Now that's the length of my vector. Now the other thing they want is the direction. Well, remember the direction was that whole, 15 degrees south of west, 10 degrees north of east. The problem is I don't have an angle measure for this angle right here. We'll call it x. So we can use trig ratios to find missing angles of right triangles. Now notice, using this as a reference point, 300 is adjacent, 640 is opposite. What ratio uses opposite and adjacent? That would be the tangent ratio. So the tangent of angle x equals the tangent ratio of opposite over adjacent. And remember, when we're trying to find the missing angle, that's where we hit second tangent. And our calculators should look like this. It's the inverse. And then we put 640 divided by 300. Hit enter and it will give you an angle measure. Let me double check that on my calculator since my notes are not here. We end up with 64.88, which would round up to 65 degrees. So is that my answer, 65 degrees? No, remember, 65 degrees, that would be south of west. Okay, you have number 10 to do. Hopefully that one is a good example. And that will help you on the homework. I do want to put one video on here just to kind of test something out on this. It's kind of a little funny thing about a vector.